In this video, we are going to talk about some more trigonometrical functions and formula, of which I've written some of the but sum and difference ratio, product ratio. Okay, there are as well some of them I'm going to put at the board, but I'm not just going to write them. I'm going to explain how you can get them instead of cramming them. Why for all these ones? The proof are quite long, so you might want to find a way to sort these things out. Okay, maybe probably count them from an examination or something else. Okay, now you notice that in this case we are having sum and difference angle ratios rather. So when we are taking the sum of two sine angles or difference or cosine, these are what we're going to get. So sine theta plus sine phi is 2 sine theta plus phi over 2 cosine subtract over 2. Okay, notice that this 2 is in front, so they cannot cancel the 2 outside. Okay, and then for this one you get pretty much the same thing. So you can just say sine theta minus sine phi is equal to this one, and this one the same thing as well. And then for products, we're having multiples of these angles. If these two confuses you, you can choose to divide through by 2, so that these two leaves here. We're just having sine times cos, cos times cos, and sine times sine. Okay, now here is some more that I want you guys to take note of. One of them is what we call the double angles. Okay, double angles. Now when we talk about double angles, what do we mean? We're talking about angles that have been multiplied by 2. For example, if we have theta, this is single, but then if we have 2 theta, this becomes what now? Double. So let's start with the first one. Let's say I ask to find the value of sine 2 theta. How are you going to find the value of sine 2 theta? We do know that this can be written as sine into bracket theta plus theta, isn't it? Now using the formula for sine, this should be theta plus theta rather, not theta plus phi. Using the formula for sine for sum and difference of angles that I gave initially from our previous video, you should be able to deal with this. Okay, in this case, this now becomes sine of theta, okay, cos of theta, right, plus cos of theta sine of theta. Now you notice we're having sine theta cos theta, sine theta cos theta. We're having the same thing. Okay, just that they are misarranged. So if I choose to rearrange this, I can write it as cos theta sine theta plus cosine theta sine of theta. Now when I sum these two, I'm going to put a 2 in front because they are the same thing, just as saying x plus x. So I'll get 2. I want to write the sign first as to make it easier for us to remember, just like I do. 2 sine theta cosine theta. I'm putting sine in front first because that is what helps me to remember this formula with ease, okay? Instead of going on through these ones. But if you put cosine in front, it doesn't matter, it won't change anything. Okay? So that is for what now? The double angle for sine 2 theta. Now how about cos 2 theta? We can follow the same procedure to give us cosine theta plus theta. That is cosine theta minus sine theta sine theta. So cosine theta is cosine squared theta minus sine squared theta. This formula looks familiar. Remember sine squared theta, or rather cosine cos theta plus sine squared theta equal to 1. But in subtract, the more you get is what now? Cos 2 theta. Okay, that is how it is being done. Now this one can also be manipulated. If I choose to replace sine squared theta from that first equation by 1 minus cos squared theta, what am I going to get? I'm going to get, I can as well get another formula. Okay, I'll write it here. Or another formula for calculating cos squared theta is 2 cos squared theta minus 1, or I can write it as 1 minus 2 sine squared theta. So these are some other formulas we can use in place of cos theta. Cos squared theta minus sine squared theta, 2 cos squared theta minus 1, 1 minus 2 sine squared theta. Now you might be wondering how I knew all these things. It became part of me with time. Okay, I had to solve these things several times, taught it, okay, over the years, and then they became part of me. Of which, if I still don't do it over the years, I will what now? Forget these things. So my advice is, all you have to do is work with these things, practice them, okay? The one you know you can't memorize for long, all you have to do is learn how it is being done. Like for this one, if you can't memorize all this, all you have to do is know this formula and work with it, you get what you want, okay? I arrived at this place by substituting sine squared theta or cos squared theta. If I substitute for sine squared theta, I'll get this. If I substitute for cos squared theta, I'll get this, but I just skipped that place, okay? So now that I've told you, you can as well make it as an exercise. And then for tan 2 theta, tan 2 theta is giving us tan of theta plus theta, and that is tan theta plus tan theta over 1 minus tan theta tan theta. This gives us tan theta plus tan theta, that's 2 tan of theta over 1 minus tan theta times tan theta, that's tan squared of theta. Okay, now that is all for double angles. Okay, this is where double angle ends. But then there are also some set of useful formulas, okay, that work when the angle is greater than 0 but less than 90 degrees. There are some formulas to use. I'm going to write it here. Okay, there are some important formula of which, when it satisfies this condition, where the angle is here 90 degrees, here are the formulas. Okay, let's start with the first one. Let's say we're having a sine theta plus b cos theta. Okay, this will be equal to, or rather let's make use of small letters, b and a. Okay, this will be equal to a. What I usually do, I'll pick the first one, sine, okay, and then pick the other one, which is the angle theta. I'll put a plus since there's a cos. Now, don't mind the way I'm deriving it. I'm not doing it mathematically. I'm doing it in such a way that I always remember how to write these formulas. Okay, so all you have to do is study it and look for a pattern that will help you work now. Remember these things. So I have sine theta plus an angle which I will call alpha. Okay, of which this alpha, take note, alpha is the tan inverse of the second one over the first one. Take note, second over first. So you have b over a. So we have b over a. Okay, and then a, this capital letter a, simply means the square of the sum of the squares, a squared plus b squared. So you see, it means I'm squaring these two. Okay, just like getting an amplitude. Even this equation is also used in what we call damp oscillation. Okay, that's another topic in physics. This equation is also useful. Okay, it's one of the equations we made use of. And then we can as well write as a sine theta minus b cosine theta will be equal to a, and then we have sine theta plus alpha again. Okay, and then again, if we have a cos theta plus b sine theta, this will be equal to a cosine of theta minus alpha, and then a cosine theta minus b sine theta will be equal to a cosine of theta minus alpha. Okay, these are the useful formulas. Like I said, there is a pattern to it. Okay, not like there is really a pattern though, but when you study it, there becomes a pattern created in your brain that will help you remember these things. Okay, it might not be a mathematical way of proving them. Okay, but that is how it's being done. So these are some other formulas that you might have to take note of. There are also triple angles, like for example, you have to find sine theta. We can make use of trigonometry, but most times, if you make use of trigonometry, it's usually very, very long. Okay, you have to find sine theta. If you have to find sine theta, you get an answer. I think that should be around 4 sine cube theta minus. Okay, it's quite long. I don't memorize these things. Okay, when we go higher, you don't have to memorize them. All you have to do is learn how to prove them. So for sine theta, we're going to have sine 2 theta plus theta and use the same way of proving it again. You get an answer. Although there's a shortcut for doing that, it is in complex number. That is something we've done in complex number. Imagine you have to find sine 5 theta. That's not complex number. Don't try proving them in trigonometry to take time. Okay, you make use of what we call the Mover's theorem to prove it in complex number. Okay, or you're asked to find sine cube theta. Take note, if you try in trigonometry to find the value of sine cube theta, you might find it in the end, but I swear I haven't seen any solution like that, but you can choose to try it as an exercise, or which it will take time. Okay, sine cube theta is quite difficult for you to find using trigonometry. What most people will do is also mix of complex number. Now, these things are very easy, but they are not under trigonometry. There are also different functions. We have exponential and hyperbolic functions, which I'm going to talk about as we proceed in our classes. Now, this will probably be where we're going to stop in our trigonometry, and then we just talk about how to convert angles from degrees to minutes to seconds and radians and the likes. Okay, so if you've gotten this far in our video from the beginning from trigonometry, kudos. I'm glad you guys probably learned something, and now I can now say that since you've watched from the beginning to the end of this video, you're definitely going to ace an A in any exam you're writing that involves trigonometry, and they are giving questions on this. Okay, trust me. Do well to subscribe, like, share, comment, if you have a question on anything. Okay, see you in the next video. Stay tuned.